Hello, good morning. We are going to solve one problem of implicit differentiation. Okay, implicit differentiation is when the function you have to find the derivative of is given not as y equals and then the function, but with x and y on both sides of the equation, right? So the topic is implicit differentiation. The instruction says find the derivative, find the implicit derivative of the following function. And the function is given not like it's usually given, not y equals and then the function with x, right? The function is given with x and y on both sides of the equation. So this is the challenge, okay? What we're gonna do is we are going to differentiate both sides of the equation, and then we will solve for y prime, for the derivative of y, okay? When we differentiate in this problem, the first term is actually a product of two functions. This is one function, this is another function, right? So if you remember the product rule for derivatives, you write the first function times the derivative of the second one plus the second function times the derivative of the first one, x to the cube times the derivative of y, which is y prime, plus, because it's a product, the function y times the derivative of x to the cube, that is 3x to the square. Okay, that is the first derivative. Then we have to differentiate y to the fourth. Y to the fourth becomes, when you differentiate it, becomes 4y to the cube times y prime. We're using the chain rule here. Y is a function. So you have the coefficient, the exponent becoming the coefficient, you subtract 1, then you have to take the derivative of y with respect to x, and this is y prime, okay? On the other side of the equation, the derivative of x squared is 2x, pretty straightforward, and the derivative of 3y is 3y prime, all right? Now, we are gonna solve for y prime, basically. We write all the terms with y prime on one side of the equation and the terms that do not have a y prime on the other side of the equation, basically. This term was here. I just removed the little dot. If they're together, they're multiplying. Right here, this second term right here, y parentheses 3x squared, does not have y prime. So we subtract that on both sides and we have it on the right-hand side of the equation, right here, okay? The next term, 4y cubed y prime, we leave it here. I just took away dot, okay? And then the term that says negative 3y prime, that was on the right-hand side, we added on both sides of the equation, and now we have 3y prime, okay? And that's gonna be equal to 2x times 2x minus y times x 3x squared. Okay, the next step is very important. What we're going to do is we're going to factor. We're going to take the common factor. All of the terms right here have one factor in common, y prime. Since our goal at the end of the session, at the end of the exercise, we want to know how much is y prime. The challenge is to solve for it, right? So you factor y prime. It's a common factor, right? And the rest is just here without the y prime. And then this side of the equation is the same. I just rewrote this to be in order. Okay. Now, since we want to clear for y prime, we have to divide both sides by this trinomial here, right? And when you divide both sides, this is what you have. And this is basically the answer. The answer will be that y prime, which is the derivative of y with respect to x, is equal to 2x minus 3x squared y all over x to the cube plus 4y cubed plus 3. Okay, this is our answer. We're going to recap a little bit. It's just a hint for the method. The method I encourage you to follow whenever you are going to find implicit differentiation problems. Okay, you can think of it as two big steps. Step one, differentiate both sides of the equation with respect to x. You have to be careful. When you differentiate dx on dx, the derivative of x with respect to x, it's of course 1, right? Dx on dx is 1. Everybody knows that. But we have to be very careful. Whenever you're going to take the derivative of y with respect to x, a y prime will appear. Okay, that's so important because actually it's y prime that you're looking for, right? The second step is to solve for y prime, in which we usually do it in like 3 little steps. Take all the terms with y prime on one side. This is what we did right here. All the terms with y prime on one side. Next step, it's very common that you do this step. It's the standard procedure. You factor out the common factor, y prime, and you divide. Okay, and then you have your answer. This is it. Thank you very much for your attention. Let us know if you have any questions. Have a good day. Thank you.